Okay, so picking back up in lesson 2.5 where we left off yesterday, we were on example 2. We were writing this polynomial function, and they gave us 3 zeros and asked us to write a standard form minimum degree equation. They gave us 3 zeros, but we actually have 4 factors, right? And the reasoning because one of our zeros was a complex number, right? It had an imaginary part. And so remember, it's the complex conjugate zeros theorem. And so we had to use the conjugate. So since they had 2 minus I, we also used 2 plus I. And then, remember when you put these in parentheses, it's x minus the 0. So I know you guys are okay with x plus 3, x minus 4. Now, for our first run through this, I put in an extra set of parentheses. Once you get better at this, you might not need those extra set of parentheses, and that's fine. But I wrote it as x minus the 0, 2 minus I. And then I also wrote it as x minus the 0, 2 plus I. Now, before we actually start multiplying this together, my recommendation is that we rewrite those without the extra parentheses. So we have the x plus 3. We have the x minus 4. Now, x minus the 0, 2 minus I. What is that if I take off those inside parentheses? It's going to be x what? Minus 2 and plus I. Because you're subtracting that 2 minus I, so you're distributing that subtraction sign. Basically, you're changing both signs on the 2 minus I. So when we do the next one, it was x. It's going to be minus the 0, 2 plus I, so it's going to be x minus 2 and minus I. Are you okay with that equivalence? And as I said, in the future, if you want to go straight to that set of parentheses without the kind of intermediate step, that's fine. Now, from here, it's all about multiplying. As I mentioned yesterday, if you have conjugates, you always want to multiply those together as a pair first. Because otherwise, if you don't multiply those conjugates together, it's going to get uglier before, it gets worse. When you multiply the conjugates together, we're going to get some canceling happening, which is what we want. Okay? So, as we go through this, I would do the x plus 3, the x minus 4, and I would do those conjugates there. So, as we multiply x plus 3 times x minus 4, what are you guys getting there? X squared, then what? Minus 4x, and then plus 3x. And I'm kind of at that point where I go ahead and put them together. If you want to wait to the next step, that's fine, because we're going to have a ton of cleanup to do in the other piece. So I'm going to say minus 4x plus 3x is minus 1x. 3 times minus 4 is minus 12. Okay? Now, for this other one, be organized, right? We're multiplying a trinomial times a trinomial. If we're multiplying 3 terms by 3 terms, we're going to end up with a total of how many terms before we simplify? A lot. Or in other words, 3 times 3, we're going to have 9 terms here. Now, it's going to clean up to 3 terms. And because these are conjugates, all my i's are going to drop out. Okay? They're all going to drop out or be able to be changed. So, we'll, honestly, once we finish multiplying these out, it's going to look a lot like this first trinomial. Okay, you ready? I'm going to take x in the first parenthesis times everything in the second parenthesis. So x times x, x squared. X times minus 2, minus 2x. And x times minus I, minus ix, if you will. Then I'm going to take that negative 2 and multiply it by everything in the second parenthesis. So negative 2 times x, negative 2x. Negative 2 times negative 2, plus 4. Negative 2 times negative I plus 2I. And then I'm going to take this I in the first parenthesis and multiply it by everything in the other parenthesis. So I times x plus ix. I times negative 2 minus 2I. And I times negative I minus I squared. So if we've done this correctly, there should be 9 terms there. Start cleaning up. Is there some canceling that's happening? Minus ix cancels with plus ix. Plus 2I cancels with minus 2I. My minus 2x and minus 2x will be like terms and go together. Plus 4 is going to be there. What do we know about minus I squared? What is minus I squared? 1, right? Because it's going to be minus negative 1. And so minus negative 1, I'm really going to call this a plus 1. Okay, so let me carry down my x squared minus x minus 12. And then let's clean up this next set of parentheses. We only have the x squared, so x squared is x squared. Minus 2x and minus 2x should be minus 4x. And then we have a plus 4. And that minus I squared became a plus 1. So plus 4 and plus 1 is a plus 5. Are you with me? I mean, I'm technically doing basic algebra, but it's a lot of it. You're okay with what we've done? If not, ask. Let me explain it. Let me figure out where I lost you. Because what are we getting ready to do now? More multiplying, yes? Okay, we've got a trinomial times a trinomial. Multiplying 3 terms by 3 terms, we're going to end up again with a total of 9 terms. So, let's go for it. I'm going to take x squared in the first parenthesis times everything in the second parenthesis. So x squared times x squared, x to the 4th. X squared times minus 4x, minus 4x cubed. X squared times 5, plus 5x squared. Now I'm taking that negative x in the first parenthesis and multiplying it by everything. So negative x times x squared, negative x cubed. Negative x times negative 4x, plus 4x squared. Negative x times 5, minus 5x. And then the negative 12 times everything in that second parenthesis. So negative 12 times x squared, negative 12x squared. Negative 12 times negative 4x, plus 48x. And negative 12 times 5, minus 60. Final step. Hang with me this long. You've made it. We just have to clean it up. Okay. I see an x to the 4th. Minus 4x cubed and minus 1x cubed. So I see a minus 5x cubed. 5x squared plus 4x squared is 9x squared. Minus 12x squared minus 3x squared is minus 3x squared. Minus 5x plus 48x is plus 43x and minus 60. Now, I'm sure you guys would have pointed out mistakes if I made them along the way, right? Okay, good news. It matches my notes. Yes?
When it's negative I squared, why is it plus 1?
So if you recall yesterday, we talked about the fact that I squared, that wrote really weird, but I squared is equivalent to negative 1. Because if you're, so we talked about I being the square root of negative 1. And so then when you square the square root of negative 1, I squared is negative 1. And so if we're doing minus I squared, that's the minus of negative 1. And so minus a negative 1, which is plus 1. Okay? In other words, you're subtracting a negative 1. If you're subtracting I squared, and I squared is negative 1, you're subtracting a negative 1. Okay? Other questions? These are the little things we have to know to survive this lesson, don't we? Now, in terms of difficulty level, I don't rank this as too high difficulty level. It's just very high on the tedious level, maybe. Okay, you're going to have to be very careful with all of your exponent signs and everything. It's tedious for me to grade, too, because I have to find your mistakes on quizzes and tests for these. So. Okay. Now, notice, they gave us 3 zeros. We ended up writing a 4th degree equation, right? But that's because they gave us 1 complex 0, so we had to use the conjugate. Okay, ready for example 3? Write a polynomial function of minimum degree in standard form with real coefficients whose zeros include x equals 1, x equals 1 plus 2i, and x equals 1 minus I. And I am kind of feeling like I would do better if this problem was higher up on the board. So I'm actually going to move my screen up. Just because I feel like you guys will be able to read it right and I'll have more room. Which means I'm going to be erasing the previous problem. Okay. So as we get started on this next problem, here we go. My starting point, f of x equals. Your thoughts? What do I need in the way of factors here?
X minus
1. Okay. Craig's got the easy one for me. If there's an x equals 1, we have to do x minus that. So x minus 1. What else?
That'd be x minus, and then in parentheses, 1 plus 2i.
Mm-hmm. Okay. So x minus 1 plus 2i. So x minus parentheses 1 plus 2i is one way to put it. Yes?
Be another x minus 1, right?
Another x minus 1 like the first one?
Oh, I read it wrong. Never mind. I saw the first x equals 1 plus 2i, and I didn't see the plus 2i.
Ah. Oh, okay, okay. I see. I was like, no? Okay. Yes. And I was just going to say, what should we put next to this one? Because we want to be able to multiply conjugates. Remember, if 1 plus 2i is a 0, what else must we use? We must use 1 minus 2i. So get that one in there next. X minus 1 minus 2i. So x minus the quantity, 1 minus 2i. Okay, next one. X minus the quantity 1 minus I. And you know what I need, right? we need one more, which is x minus the quantity 1 plus I. Because 1 minus I has the conjugate 1 plus I. Okay, so don't forget those conjugates. Now, maybe you wrote your first line like this. Maybe you took off those extra parentheses already, and that's fine as well. So we know we have x minus 1, x minus the 1 plus 2i. Are you getting what's happening here? That minus distributes, so it's x minus 1 minus 2i. X minus the 1 minus 2i, so that minus distributes, x minus 1 plus 2i. Next one, it's x minus the 1 minus I, so distribute x minus 1 plus I. And the last one, distribute that minus, x minus 1 minus I. Okay, I've already suggested what's best to multiply first are conjugates, right? Which means we have this lonely x minus 1 out front. He's going to stay lonely for a bit, okay? Because we're going to multiply the people that, we're going to multiply the ones that have a partner. So, you ready? Got lots of room to write, yes? Yeah, you show up when we go to check this homework without some serious work on some of these, I'm not giving you credit, just saying. You're not magically coming up with this answer without doing some multiplication, huh? Okay, so x times everything in this next parenthesis. So x times x. X squared minus 1x plus 2ix, right? Gosh. Minus 1 times everything in the next parenthesis. Minus 1x plus 1 minus 2i. And then minus 2i times everything in the next parenthesis. Minus 2ix plus 2i minus 4i squared. Now, that was multiplying those two right there, yes? We also need to multiply those two. I don't know, you can pick. Do you want to clean up that previous one, or do we want to go ahead and multiply the next one? You know, it all has to happen one way or another. So, I'm going to go ahead and multiply this next one, then we'll do a bunch of cleanup. So that means I'm same way I've been doing these. So I'm going to say x in the first parenthesis here times x in the second parenthesis here. So x times x, x squared. X times minus 1, minus 1x. X times minus I, minus ix. Then it's the minus 1 times everything in the next parenthesis. So minus 1x. Minus 1 times minus 1 is plus 1. Minus 1 times minus I is plus 1i. Then it's the I times everything. I times x, so plus ix. I times minus 1, minus 1i. I times minus I, minus I squared. X minus 1 is still carrying down. I'm not doing anything fancy with that. Okay. In that middle set of big parentheses, is there some canceling that can be done, I hope? Two ix minus 2ix is gone. Minus 2i plus 2i is gone. And notice all my regular i's are gone, yes? Don't force it, because if you made a mistake, that could be a mistake elsewhere, so go back and check. And then what are we going to know about this minus 4i squared? Well, minus 4 times I squared, so I squared is negative 1. Minus 4 times negative 1, this is really going to be a plus 4 that we'd like to include, right? Because we're thinking of that as minus 4i squared. So minus 4 times negative 1, which is positive 4. Okay, so let's clean up this set of parentheses here. I have x squared minus 1x, and minus 1x is minus 2x, plus 1 and plus 4 is plus 5. Repeat the process on that last parenthesis if you haven't already. Let's see. Minus ix cancels with plus ix. Plus I cancels with minus I. And I have a minus I squared going off the edge of my screen here. Minus I squared is going to be minus negative 1, so plus 1. Okay, so let's write that out. I've got x squared, minus 1x, and minus 1x is minus 2x. Plus 1 and plus 1 is plus 2. Now what? Multiplying again, right? There's a reason I moved it up. I wanted to make sure I had plenty of room to write here. Okay, at this point, I'm going to go with technically it doesn't matter what you multiply. We have 3 sets of parentheses, yes? So you have to pick 2, get those multiplied, simplified, and then multiply the other one in. I think I usually save my x minus 1 for last. That's just me personally. It doesn't really matter at this point. It matters when you have conjugates. At this point, it's just multiply. Pick and multiply. So I'm going to keep my x minus 1. And I'm going to follow the same process I've been following all morning, right? So x squared in the first parenthesis times everything in the second parenthesis. X to the fourth minus 2x cubed plus 2x squared. Then it's negative 2x in that first parenthesis times everything in that last parenthesis. So minus 2x cubed, minus 2x times minus 2x, plus 4x squared, minus 2x times 2, minus 4x. And then it's 5 times everything in that last parenthesis. Plus 5x squared, minus 10x, plus 10. I'm not going too fast here, am I? Try not to go too fast and try not to go too slow. X minus 1, I carry down. Notice I carry down that every time because I don't want to forget about it. And I'm afraid if I don't write it down, I'll forget about it. Let's see, I know I have an x to the fourth, minus 2x cubed, and minus 2x cubed. It's minus 4x cubed. Plus 2x squared plus 4x squared is 6x squared. Plus 5x squared is 11x squared. Minus 4x and minus 10x is minus 14x. And then plus 10. Again, no one's arguing me, so please argue me if I make a mistake. I'll be honest, I just checked my answer key to make sure that I'm on the right track because I don't want to continue and be wrong. Okay, now what? It's easier multiplying at least. I'm going to take x times everything in the second parenthesis, and then I'm going to take minus 1 times everything in the second parenthesis. So x times everything. So basically just increase each power. X to the 5th minus 4x to the 4th plus 11x to the 3rd minus 14x to the 2nd plus 10x. Now I'm going to take everything and multiply by negative 1, which basically means I take all the terms as is and change their signs. So minus x to the 4th plus 4x cubed minus 11x squared plus 14x minus 10. And then clean up like terms on that last step. So I have an x to the 5th minus 4x to the 4th minus x to the 4th. It's minus 5x to the 4th plus 11x cubed plus 4x cubed is plus 15x cubed minus 14x squared and minus 11x squared is minus 25x squared plus 10x plus 14x is plus 24x minus 10. Those of you that worked ahead, are we meeting in the end? Or did no one decide? Was no one brave enough to get that far ahead? Let's see, it matches, and I'm checking. It matches my answer key here. So, again, difficulty level, it's not hugely difficult. It's tedious. Very, very tedious. So, yes?
Where'd you get the other negatives?
So you're talking about this negative x to the 4th right there? Okay, so that was, so when I started right here with this minus 1, and I started distributing it, is where that one came from. So negative 1 times x to the 4th is going to be minus x to the 4th. Does that answer the question there? Okay. Obviously, I expect to see work on those. Take your time on them, okay? I mean, I could have moved just faster, but the faster we move, the more mistakes we make. So. Okay. When you're ready, turn the page and start looking at example 4. Okay? Because this relates to what we've done previously. Let me think. Okay. Example 4 is find all zeros. All. Okay? All zeros, it was that keyword on that IXL you had that you happened at the end, of this function f of x, and write f of x in its linear factorization. So basically, once we find the zeros, we're writing them as factors. The big key is to find the zeros. How many zeros are there going to be when we get done?
At least, I mean, at most.
If we're just talking real, it's at most 5. Since we are finding all, it is exactly 5. And based on the name of the game today, some of those zeros will likely be complex. They will likely have imaginary parts. Okay? So keep that in mind. So, all zeros, and there will be 5 somehow or another. Okay, what do you remember? How do we do this? Okay, so officially we find our PRRs, right? And PRRs, and I'm not even going to write this very officially here. Our PRRs are factors of 8 on top. So factors of 8 are 1, 2, 4, and 8 over factors of 1, which is just 1, right? Okay. And again, it's not questioning me on my PRR, so I'm not even going to write it out more than that because I can see what I need to see. What do we do? Synthetic division. Which one should we start with? I see some graphing calculators coming out because what is my best suggestion here? Graph it and let the graph give you a hint, right? So start graphing that. Graph it, or you guys gonna be able to get it figured out?
Or -2,
Does that sound right? So it looks like it's going through 3 nice, neat whole numbers that happen to be from my PRR list, even better, right? -2, 1, and 4. And if you're not getting that, my guess is you didn't type it into the calculator, right? Because no, I haven't graphed it yet. However, that's what I have in my notes, okay? Goes up through -2, down through 1, back up through 4. Okay? I don't even feel like I have to zoom it out. I feel like I see what I need there. Okay, so what do we do? Pick one of these numbers and start, yes? Does it matter which one you start with? Nope, doesn't matter. So I'm just going to go with -2. So -2 goes in the box. And you've got our row of numbers next to the box, yes? Which are my coefficients in order. Make sure you have placeholders if necessary. So I see 1, -3, -5, +5, -6, and 8. Okay. You guys good on synthetic? Drop the 1, -2 times 1, -2. Add, -3 and -2 is -5. Multiply, -2 times -5 is 10. Add, -5 plus 10 is 5. Multiply, -2 times 5, -10. Add, 5 and -10 is -5. Multiply, -2 times -5 is 10. Add, -6 plus 10 is 4. Multiply, -2 times 4 is -8. And add, and we get 0. Which is what we expect, right? If you don't get 0, stop, go back, rewind, figure out what went astray. Now, okay, so -2 works as we expected. We got a remainder of 0. Now what? Okay, so we're going to use this new set of numbers right here, yes? And we're going to use it with the next one. So, in whichever one you want, I'm going to use 1. And my new set of numbers then are what I'm going to use up here, yes? It is hugely important. You have to use that new set of numbers, folks. You have to. Or you're not going to be able to find our imaginary ones at the end. Okay? So, I'm going to use 1 is going on here? 1. Oh, I still didn't get it. Oh well. Negative 5, 5, negative 5, and 4. Okay. Drop the 1. 1 times 1 is 1. Negative 5 and 1 is negative 4. 1 times negative 4. 5 plus negative 4 is 1. 1 times 1. Negative 5 plus 4 is negative 4. 1 times negative 4 is negative 4. And we have a remainder of 0, which again, we expect. So now we've used 1. Now what? Keep trying all that you have, right? Which means now we're going to use 4. What do we use with 4? Our new set, right? Each time you're using the new set. So now I'm going to use 1, negative 4, 1, negative 4. And you know how to synthetic divide. Drop the 1, multiply, add 0, multiply 0, add 1 plus 0 is 1, multiply, remainder of 0. Okay. Now, we have 3 working zeros. We need 2 more. What does that 1, 0, 1 represent?
Coefficients.
Coefficients. So it's going to be 1x to what power?
2.
Yeah, it's 1x squared there. Officially, you could say plus 0x and plus 1, right? And keep in mind, first of all, I can just count backwards if I want. Remainder, constant, x squared. Or we can look at, okay, this was x to the 5th. So then the next set is x to the 4th. The next set is x to the 3rd. So now we're at x squared. So take this equation and what? Set it equal to 0. Which the short of that is x squared plus 1 equals 0. How do you solve x squared plus 1 equals 0? Okay, subtract 1. So then I have x squared equals negative 1. If we're working in real numbers, we'd say, oh, stop, can't solve that. However, we're expecting imaginary, so we can solve this, yes? How do you solve? We're going to take the square root. Whoops, let's get the square root in the right place there. What is the square root of negative 1? I and minus I. Remember when you take the square root in an equation setting, you have to account for the positive and negative roots? Here you go. So the square root of negative 1 is plus or minus I. Well, guess what, folks? Do we have 5 now? We have 5 zeros. How do we express our answer? Linear factorization. So we have all the pieces. It's just putting it in linear factorization. So I'm going to say f of x equals. I first had negative 2. So that's x minus negative 2, or in other words, x plus 2. Then I used 1, which is x minus 1. Then we used 4, which is x minus 4. Then we came up with I, which is x minus I. And we came up with negative I. X minus negative I is x plus I. We just factored that is what we did. Totally different factoring than what you learn in algebra. It's using synthetic division to factor that. Okay? Okay, questions there? Okay. We were supposed to be done with this lesson today. I think this is catching up with me yesterday for not getting started right away, but it's all right. Okay, so obviously we will be finishing example 6 tomorrow, and yes, we will be going through it because it is a big deal. There is a new piece there. So if you just start reading example 6 right there, notice it says the complex number z equals 1 minus 2i is a zero of this given function. Find the remaining zeros and write it in linear factorization. Guys, here's the catch. You graph this one right here, you don't find any real zeros, which is why you have to get started with what they give you. Okay? Because there are no real zeros. So they're giving us one of the imaginary zeros, and we'll go from there. Okay? So, feel free to go ahead and start the homework. Obviously, you can obviously some of these are going to be big, right? So, I think my original plan was probably to move on to the next lesson tomorrow, and I'd really like to do that, but you know what? I had penciled in that we might not start 2-6 until Friday. So, okay, we'll start with this problem tomorrow, and then plan to, I'd say, have some of the homework done, and then we can kind of get some questions along the way if there's things you're stuck on, because on Friday I'll want to come in, get them graded, and get into 2-6 pretty quickly if we can. Okay? Sound good?